Right now in 2026, every single season, millions of families are quietly spending money on something they could have had for free, and the plants themselves have been trying to give it to them all along. This is not about survival theory or extreme prepping. This is about a real, documented, scientifically backed skill that entire civilizations built their food systems on for thousands of years, until a handful of corporations quietly made most people forget it. Stay with this until the very end, because the last idea revealed halfway through this video is the part that will genuinely change how you grow food, starting from your very next harvest. The world is more expensive in 2026 than it has ever been, and fuel costs have surged again due to ongoing supply instability linked to conflicts in the Middle East. And those fuel prices do not just hit your car, they hit every single truck that carries food to your supermarket, every tractor that plants a field, and every shipping container that moves a seed packet from a warehouse to a store shelf. The cost of living has squeezed household budgets so tightly that millions of people have turned or returned to growing their own food as a genuine financial strategy, not just a hobby. But here's the quiet trap that almost no one talks about. Even people who grow their own food are still dependent on corporations because they keep buying seeds every single year. The average home gardener or small-scale urban farmer spends between $30 and $100 or more on seeds every single season. And for most of them, this happens every year, like clockwork, and they never question it. They do not realize that the food they already grew, the tomatoes they ate in summer, the peppers they sliced for dinner, the beans they cooked last week, contains inside it everything needed to feed a family for decades. That realization is the beginning of something important, and it is exactly what this is about. Seed saving is the art and practice of preserving and sharing seeds from desired open-pollinated plants. It has many benefits and motivations that include improving the adaptability of a crop to a region or microclimate, preserving cultural traditions and foods, growing for nutrient density and flavor preferences, saving on the cost of seed purchases, and connecting to local communities through seed sharing. But before going into exactly how to do it, it is critical to understand one thing that the seed industry does not advertise loudly, and that is the difference between the seeds you can save and the seeds you cannot. To guarantee that your seeds will produce the same plant variety the following growing season, you should only save seeds from open-pollinated and heirloom varieties. And while all heirloom seeds come from open-pollinated varieties, not all open-pollinated plants are heirloom plants. Open-pollinated seeds come from plants that are fertilized by natural methods like pollinator insects, birds, rain, and wind. And when two plants of the same variety are cross-pollinated by one of these methods, the resultant seed grows into a plant that is similar to the parent plants with only slight variations, and these variations lead to genetic diversity which allows the seeds to gradually adapt to the local climate. Think of this adaptation as nature doing the agricultural research for you, for free, generation after generation. Heirloom seed varieties originate from open-pollinated plants and have a history of passing down desired traits from parent plant to child plant, and these valuable characteristics are developed through years of cultivation and may include hardiness, flavor, productivity, pest and disease resistance, and climate adaptability. And to be considered an heirloom variety, the seeds typically must originate from plant varieties that are at least 50 years old. Before the early 20th century, nearly all seeds available to farmers and gardeners were open-pollinated, and commercial hybrid seeds did not become widespread until the 1930s, which means many of the world's historic crop varieties were maintained solely through open-pollinated seed saving. That is a staggering fact when you sit with it, because it means every civilization that fed itself before the 20th century did so using seeds it grew and saved itself, and that knowledge did not disappear. It was just buried under convenience and commerce. Now here is where hybrid seeds enter the picture, and this is the part the industry depends on, most people not fully understanding. Hybrid seeds are created by cross-pollinating two different but closely related plant varieties to produce offspring with desired traits, such as disease resistance or higher yields. And while hybrids can produce excellent results in terms of uniformity and productivity in the first generation, saving seeds from hybrids is not recommended because the offspring from saved hybrid seeds are unpredictable and often do not retain the same traits as the parent plants, and they may revert to traits from one of the parent plants or produce completely different characteristics. The easiest way to tell if a seed is hybrid is to check the seed packet or catalog, as hybrids are almost always labeled with F1 or hybrid. So if the packet says F1, you are locked into purchasing seeds again next year, and the year after, and the year after that, because the plant will not reproduce itself faithfully. This is not an accident of nature. It is a design feature of the commercial seed system, and understanding it is step one of breaking free from that dependency entirely. Step one of the actual process, then, is identifying which crops you already grow or plan to grow that come from open-pollinated or heirloom varieties, and if you do not currently know, this is the season to start finding out. Open pollinated varieties are like dog breeds. They will retain their distinct characteristics as long as they are pollinated with the same variety. Seeds saved from open pollinated varieties will produce plants identical to the parent. This consistency is the foundation of the entire practice, and it is what makes seed saving a genuinely perpetual system rather than a one-time experiment. Now, the first group of plants to start with are what seed savers call the easiest beginners, and these are the self-pollinators. Plants can be roughly divided into 3 types of pollinators: self-pollinated, wind-pollinated, and insect-pollinated. And plants that self-pollinate, like tomatoes, peppers, beans, lettuce, peas, and broccoli, are the easiest to save seed from because they rarely cross-pollinate. The reason self-pollinators are so forgiving is that the pollen transfer happens inside the flower itself before it ever fully opens. So even if another variety is growing 2 feet away, the genetic exchange almost never happens. Start with tomatoes, because they are among the most rewarding seed-saving crops a person can grow. And one mature tomato fruit can contain between 150 and 300 seeds, any of which, properly saved, can produce an entirely new plant. The key with tomatoes is the fermentation method, which sounds complicated but takes only 3 to 5 days and mimics a natural process that happens in the wild when a tomato falls and rots on the ground. By placing tomato seeds in water and allowing them to ferment, you will break down the seed coats and kill off many of the germs that may prevent the seeds from starting. And when the seeds sink and separate from the pulp, you can strain, wash, and dry the seeds. Let the tomato fully ripen on the vine, past the point where you would normally eat it. Scoop out the seeds and pulp into a glass jar with a small amount of water. Cover the jar loosely and leave it at room temperature for 2 to 4 days until a layer of mold forms on the surface. The mold layer is not a problem. It is actually part of the process, because the gel coating around each seed contains natural germination inhibitors, and the fermentation breaks down that coating and frees the seed to germinate powerfully in the soil. After the fermentation period, pour the mixture through a fine strainer, rinse the seeds thoroughly under cold running water, then spread them in a single layer on a plate or a piece of parchment paper and allow them to dry completely for 7 to 10 days in a warm, dry location away from direct sunlight. Once dry, the seeds should snap rather than bend when pressure is applied. And that snap is the confirmation that moisture content is low enough for safe long-term storage. Now, while the tomato is working through its fermentation process in the jar on your kitchen counter, let us move immediately to the next crop in the chain, the pepper. Because the contrast in technique reveals something fascinating about how diverse plant biology actually is. Unlike tomatoes, peppers do not require fermentation at all because pepper seeds are dry seeds that are ready to be saved as soon as the fruit is fully ripe. For most wet seeds, like seeds in tomatoes, squash, peppers, zucchini, and eggplant, you should wait until the crops are overripe before you save the seeds. For peppers specifically, this means letting the fruit stay on the plant until the color deepens completely, whether it turns red, orange, yellow, or chocolate, depending on the variety, because a green pepper is an immature fruit with immature seeds that may not germinate reliably. Slice the pepper open, scrape the seeds from the core onto a dry plate, and let them air dry for 1 to 2 weeks. Then store them in a paper envelope inside an airtight glass jar. Bush beans, tomatoes, peppers, lettuce, and peas are all self-pollinating plants that have little chance of cross-pollination. This matters because it means you do not need to go to extraordinary lengths to separate pepper varieties as long as you are not growing them touching each other in a tiny container. And the seeds you harvest will be true to type. Now transition from peppers to beans, because beans represent one of the single most efficient seed-to-food ratios in all of backyard farming, and the savings become almost absurd when you calculate them. One bean plant, grown to full maturity and allowed to dry on the vine, can produce anywhere from 15 to 40 seeds, depending on the variety. And every one of those seeds is both food and next year's crop simultaneously. For dry seeds like peas, beans, lettuce, and grains, simply harvest once the seeds are hard and dry. For peas and beans, you know they are ready if they rattle in the seed pod when shaken. That rattling sound is one of the most satisfying confirmations in gardening, because it means the plant has completed its entire reproductive cycle and handed the next generation directly to you. Allow bean and pea pods to dry completely on the plant, which means leaving them well past the point where you would normally harvest for eating, then pull the dried pods, shell them by hand, check each seed for damage or discoloration, and store only the firmest and most uniformly colored ones. Select the most vigorous disease-free plants with desirable traits for seed collection, mark potential seed plants early in the season with bright ribbons or stakes, and choose specimens that show resistance to local pests, weather conditions, and diseases, picking plants producing abundant high-quality fruits or flowers with ideal size, color, and flavor characteristics. This act of deliberate selection is where seed saving becomes more than just collecting. It becomes a form of plant breeding that you're doing in your own garden, quietly and continuously, tuning your crops to your specific soil and climate over the span of years. Open pollinated plants can adapt over time to the specific conditions where they are grown, and if you save seeds from the same variety year after year in the same location, the plants may gradually develop traits that make them even better suited to your soil, climate, and growing methods. And this process is called landrace adaptation, and is one reason many traditional varieties are so resilient. Landrace adaptation is one of the most powerful and least talked about tools in the low-cost food growing toolkit, and it represents a compounding investment that gets stronger with each passing season. Now, step into slightly more challenging territory, the squash and the cucumber family, because this is where cross-pollination becomes a real concern, and the technique shifts dramatically from what you did with tomatoes and peppers. Crops that are wind or insect pollinated, including cucumbers, melons, corn, pumpkins, gourds, and squash, will readily cross-pollinate. The squash commonly grown in gardens can fall into one of three species: Cucurbita maxima, C. moschata, and C. pepo, and these species typically will not cross-pollinate with each other. This is actually very good news for the home gardener, because it means a butternut squash, which is C. moschata, will not cross with a zucchini, which is C. pepo, even if they are growing side by side in the same bed. But two varieties of the same species, for example, two different types of C. pepo, absolutely will cross, and the seeds that result will be a genetic gamble that may produce something very different from either parent. One method to control this is to use blossom bags, and this is a technique that allows growing all the varieties wanted close together in one continuous garden space. And while blossom bags specifically marketed for seed saving can be costly, a money-saving alternative is to use little mesh party favor bags, which work just as well for a fraction of the cost. When the plant sets its flowers, before the flowers open, slip the bag down onto the branch over a bunch of flowers and tighten the drawstring, and as the flowers open, they should all be contained inside the bag. And each time you walk past the bag, gently shake the branch, which will cause those flowers to pollinate each other. And after the fruits set on that branch, remove the bag and tie a ribbon or string on the branch, so that later, when harvesting the fruit, you can use only the fruit from the marked branches for seed saving, and this guarantees those seeds carry the genetics of that plant only. This single technique, the blossom bag and marking method, unlocks the entire squash and cucumber family for seed saving, even in small gardens with multiple varieties growing close together. Using a clean paintbrush to transfer pollen from one flower to a newly opened flower on the same plant, or another plant of the same variety, is called hand pollination. And it is a good idea to use blossom bags to cover the flowers until they open, then remove the bags for hand pollinating, and replace the bags afterward if you want to ensure no cross-pollination occurs. For squash specifically, allow the fruit to stay on the vine for at least 1 month past the point of normal harvest for eating. Because even though the squash looks ready to eat, the seeds inside are still maturing, and harvesting too early is one of the most common reasons seed saving fails. Some fruits are market mature or ready for eating long before the seed is mature, and examples of these include carrots, cucumbers, eggplants, peas, green beans, summer squash, and cabbage. This is a concept that transforms how you think about the plant, because you begin to understand that the fruit you eat and the seed that carries the next generation are operating on different timelines inside the same piece of food. Now, the story takes a turn that most people miss entirely, because seed saving is only half of the equation of never buying seeds again. And the other half involves something even simpler, something you may already be doing without realizing its full potential. This is vegetative propagation, and it is the ability of plants to reproduce not from seeds at all, but from pieces of themselves. And it is one of the oldest and most powerful food production technologies humans have ever used. Instead of throwing away vegetable scraps, they can be reused to regrow a plant in a process called vegetative propagation. Several plants can be propagated from seemingly spent kitchen scraps, and some even begin sprouting on their own if they are not used up quickly enough. Let us start with potatoes, because potatoes are perhaps the single most dramatically efficient crop for vegetative propagation, and the biology behind it is genuinely extraordinary. Unlike true root vegetables like carrots and beets, tubers actually regrow from pieces of themselves. And potatoes are one of the very best vegetables to regrow from scraps. And if you're looking to get a lot of food from your grocery store scraps, potatoes are the crop for you, because those potato sprouts are the beginning of the plant regrowing itself. And every single one of the eyes is capable of creating a new plant that will grow about 5 to 8 more potatoes. Think about that compound effect. You start with one potato, cut it into sections each containing at least one eye, and each section becomes a plant that produces 5 to 8 new potatoes, which can then each be cut and planted again the following season. Building on themselves, almost without limit, cut your tuber into small sections, making sure there is at least one eye in each section. Leave small potatoes whole, set these sections out for 1 to 3 days to scab over before planting in the ground, which will prevent the tuber from rotting in the soil. And plant outdoors with the eye facing up once the threat of frost has passed, either in the ground or in a large container filled with well-draining soil. The scabbing step is one that most beginners skip and then wonder why their potatoes rotted in the first week, and it is one of those small pieces of knowledge that makes the difference between a successful harvest and a failed one. Now, while the potato is establishing itself in the ground through vegetative propagation, move the story immediately to garlic, because garlic operates on a completely different biological mechanism. And the contrast is what makes understanding vegetative propagation so rich. A garlic bulb is made up of individual garlic cloves, and you can hold one clove back and plant it in your garden in the fall, root side down with the tapered end pointing up, and the next spring or summer you can harvest a full bulb of garlic, and it is ready when the tops begin to turn yellow and fall over. So from one clove you spent 30 cents on at a market, you can harvest an entire bulb containing 8 to 12 cloves. And each of those cloves can be replanted, meaning the multiplication factor from a single purchase is enormous if done deliberately every season. Save 1 to 2 cloves from every garlic bulb used in your kitchen, and you can grow your very own garlic plants. And this works best with organic garlic from the store or the farmer's market. And if your garlic has already sprouted in your pantry, then all the better. The sprouting you see in a forgotten garlic bulb in the kitchen is not the garlic going bad. It is the garlic trying to reproduce itself. And that biological urgency is exactly what you want to harness. Now, while garlic cloves are sitting in the fall soil preparing for their slow winter rest before spring, let us look at the crop that requires neither soil nor sunlight to begin its regeneration: the green onion. Green onions are arguably the easiest and most popular vegetable to regrow from scraps, and all you must do is cut them about an inch from the roots and leave them in a glass of water. This is a great first kitchen scrap gardening project because the green part of the onion will grow back quickly, and in less than 2 weeks it will be tall enough to snip the top off to eat, and then you can keep planting and enjoying them continuously. The green onion method is something that costs literally nothing beyond a glass of water and a window ledge, and it means that a single bunch purchased from a market can become a permanent, indefinitely renewable supply with no further purchase required. While green onions grow in water on your windowsill, the celery that you may be cutting for salads is quietly waiting for the same opportunity. Cut stalks off about 2 inches from the bottom of the celery bunch and place that white base in a shallow bowl of water without submerging it. And after several days, roots will begin growing from the base, and leaves will grow from the top. Place the base in a bowl of water where it can get adequate sunlight, and as new leaves begin to sprout from the middle, allow for it to gain thickness for about a week before transferring it into a pot of soil. What is happening biologically in both the celery and the green onion is that the living cells at the base of the plant retain the genetic blueprint and the metabolic capacity to restart growth as long as moisture and light are present. And this is the same principle that has allowed human civilizations to propagate food crops long before the concept of seed packets existed. Now, move to sweet potatoes, which represent one of the most remarkable and visually dramatic examples of vegetative propagation in the entire plant kingdom. If placed in water, sweet potatoes will form new sprouts called slips that you can plant in your garden. To produce more than one plant, cut a sweet potato in half and suspend it using toothpicks in a shallow container of water, and roots and sprouts will begin to grow in a few days. Each slip is a complete new plant, and a single sweet potato can produce 5 to 8 slips, each of which when planted in soil will produce a vine that yields a cluster of sweet potatoes in just 3 to 5 months, depending on your climate. Remove the slips from the sweet potato by cutting them at the base when they are about 5 to 6 inches or 13 to 15 centimeters long. And once all threat of frost has passed, plant the slips out in your garden. The efficiency here is staggering because the original sweet potato, which may have cost a single coin at a market, essentially becomes a planting factory that produces dozens of new plants without any seed purchase involved at all. Now, transition from the sweet potato to herbs, because herbs represent a completely different category of vegetative propagation called stem cuttings, and the technique is slightly different but equally powerful. Basil is easy to regrow from a couple of stems you have left over from a recipe, and in this case, you're doing something called propagating, or encouraging the stems to grow roots and become entirely new plants. And you will have the most success if your basil has not been stored in the refrigerator. You should select the stems with the healthiest, freshest looking leaves. Cut a stem at a slight angle so that it is about 4 inches or 10 centimeters long. Remove the lower leaves from the cutting. Place the stem in a glass of fresh water, ensuring no leaves are submerged. Set the glass somewhere that gets bright but indirect light. Refresh the water every couple of days. And after 10 to 14 days, the cutting should have new roots forming at the bottom. And once these roots are about 1 inch or 2.5 centimeters long, transplant the rooted cutting to a pot filled with well-draining soil. That timeline is important to internalize. 10 to 14 days from a piece of a stem to a fully rooted new plant, with no seed, no special equipment, and no cost beyond a glass of water in a spot near a window. Herbs like basil and cilantro readily regrow from stem cuttings. And while basil and cilantro are working through their water rooting phase in glasses by your sink, step back and look at what has been built across all of these techniques together, because this is where the full picture comes into focus. You now have seeds fermenting from tomatoes, dry seeds collecting from peppers and beans, blossom-bagged squash maturing on the vine with guaranteed genetics, potatoes scabbing in the kitchen before going into the ground, garlic cloves establishing roots in the fall garden, green onions perpetually regrowing in water on the windowsill, celery regenerating in a bowl, sweet potato slips forming from a single tuber, and basil cuttings rooting in glasses throughout the kitchen. And not a single seed packet has been purchased. This is the system, and it is not theoretical. It is what farmers and home growers did for the entirety of human agricultural history until roughly the middle of the 20th century. There is no guarantee that all crop varieties will be maintained and offered by seed companies indefinitely. Indeed, many have been dropped and become unavailable to growers. And saving seeds allows you to select and improve crop characteristics like flavor, vigor, nutritional quality, and regional adaptation. And these are not always the same goals for seed companies and breeders who may focus on commercially important traits. That truth should sit heavily, because it means the seed companies and the home grower are optimizing for completely different things, and the home grower who saves seeds is developing something no corporation can sell, a crop that is perfectly adapted to their own specific conditions and preferences. Now the question is, once you have collected all of these seeds and separated them from the pulp and dried them carefully, how do you actually store them so they remain viable for years rather than months? Past research has identified the optimal storage conditions for seeds, which requires low temperature and low humidity to slow metabolic activity and keep seeds viable. Seed viability is tied to the seed's ability to respire slowly, using stored sugars to sustain this process until the time is right to initiate growth. The enemy of stored seeds is not time itself. It is the combination of heat and moisture. And controlling those two variables is the entire science of seed storage in its simplest possible form. Proper seed storage ensures a high percentage of germination at planting time, and once seeds have been cleaned and dried, placing equal amounts of silica gel and seed into paper envelopes is recommended, and it is important to always label envelopes, especially when saving different varieties of the same plant species, and each envelope should be placed into a clean glass jar. And after 1 to 2 weeks, the silica gel should be removed from the seeds, and the envelope returned to the glass jar, and jars should be stored in a cool, dry place until you are ready to use the seeds. Silica gel packets, which are the tiny packets often found in shoeboxes and packaged foods, are desiccants that pull residual moisture out of the air inside the storage container, and they can be reused by drying them in a low oven for about 2 hours, when they change color to indicate saturation. Storing seeds in a refrigerator or freezer is probably the most practical approach for home use, and it pays to keep seeds in a tightly sealed container, such as a Ziploc bag or a jar with a screw-tight lid to limit fluctuations in humidity. Emerging sustainable seed storage technologies such as innovative drying techniques, low-energy drying methods, and vacuum sealing are essential for preserving seed viability and quality. Even without advanced technology, a simple combination of thoroughly dried seeds, a sealed glass jar, a silica gel packet, and a refrigerator shelf creates storage conditions close enough to professional standards to keep most vegetable seeds viable for 3 to 10 years depending on the species. Under average storage conditions in a cool, dry place away from moisture, the storage life of many common vegetable seeds includes viable for 1 year in storage. Beans, broccoli, carrots, corn, most herbs, leeks, lettuce, okra, pea, peppers, and spinach. But under optimized cold and dry conditions, those numbers extend dramatically, and this is proven at the institutional level by the most extreme seed storage facility ever built. Way up north, in the permafrost, 1,300 kilometers beyond the Arctic Circle, is the world's largest secure seed storage. The seed bank is 130 meters inside a sandstone mountain on Spitsbergen Island and employs robust security systems. And the facility is managed by the Nordic Genetic Resource Center, and Spitsbergen was considered ideal because it lacked tectonic activity and had permafrost, which aids preservation, and its location, 130 meters above sea level, keeps the site dry even if the ice caps melt, and locally mined coal provides power for refrigeration units that further cool the seeds to the internationally recommended standard of minus 18 degrees Celsius. The seed vault has the capacity to store 4.5 million varieties of crops. The seed vault has the capacity to store 4.5 million seed samples, and each sample contains an average count of 500 seeds. So a maximum of 2.25 billion seeds can be stored in the facility. The low temperature and moisture level ensures low metabolic activity, keeping the seeds viable for decades, centuries, or in some cases thousands of years. And the permafrost ensures the continued viability of the seeds if the electricity supply should fail. The governments of the world built a facility buried 120 meters into an Arctic mountain specifically to protect the genetic diversity of food crops. And the reason they did this reveals something that should alarm every single person who eats food. Worldwide, more than 1,700 gene banks hold collections of food crops for safekeeping, yet many of these are vulnerable, exposed not only to natural catastrophes and war, but also to avoidable disasters such as lack of funding or poor management, and something as mundane as a poorly functioning freezer can ruin an entire collection. And the loss of a crop variety is as irreversible as the extinction of a dinosaur, animal, or any form of life. The Icarta gene bank in Syria, one of the world's most valuable collections of seeds containing some of the oldest varieties of wheat and barley, was abandoned due to the civil war. And Icarta reestablished its headquarters in Morocco and Lebanon and restarted the gene bank in 2015 using seeds from the Svalbard Vault, which was the first ever withdrawal from the facility. That withdrawal was not symbolic. It was a real civilization reaching back into its own seed library after war destroyed the original. And the fact that those seeds existed in Svalbard is the reason those wheat and barley varieties still exist today. As of February 2025, over 1.3 million seed samples were stored in Svalbard, representing more than 6,200 plant species. Now bring this back to the individual grower, because the same principle that drives the Svalbard Vault, protecting genetic diversity through deliberate, low-cost, long-term seed storage, applies directly to every home garden and every balcony container and every windowsill herb pot. Preservation and improvement of locally adapted varieties are critical for improving food security and helping increase regional biodiversity. When you save seeds from your best performing tomato plant, you're doing what scientists at the Svalbard Vault do at planetary scale, and you are doing it for your street, your neighborhood, and your family. The role of community-based seed banks and participatory plant breeding in promoting seed resilience against climate change is a critical area of research and practice. Across the world in 2026, community seed libraries and neighborhood seed swaps are growing rapidly as people recognize that the distributed, decentralized storage of seed diversity is as important at the local level as the Svalbard Vault is at the global one. Sharing seeds with others helps grow community connections as people save, share, and tell the stories of the seeds and their cultivation with each other. A seed swap is not a small thing. It is a direct exchange of genetic heritage, locally adapted knowledge, and food independence between neighbors. And it builds a network of food resilience that no supermarket supply chain can replicate. Now return to the biennial crops, because there is one category of seed saving that most beginners overlook entirely, and it involves plants that do not produce seeds in their first year at all, which sounds like a problem, but is actually a fascinating piece of plant biology. Biennials, such as carrots and onions, do not flower until their second growing season after they have gone through a cold period called vernalization. Self-pollinating seeds that are biennial crops, such as carrots and beets, are harder to save, since they need 2 seasons to set their seeds. This means that if you want to save carrot seed, you eat most of your carrots in the first autumn, but leave the best performing root in the ground through the winter, and in the spring of the second year, the plant will send up a tall flowering stalk and eventually produce hundreds of seeds. After selecting the best roots and storing them in a root cellar over winter, planting them in late April about 20 inches apart will cause them to grow into tall seed heads loaded with seed clusters, and they become ready for harvest in August, providing a generous supply of seeds for the following year. This is a technique practiced by traditional farmers in cold climate regions for centuries, and it is what allowed communities in Northern Europe and Asia to maintain carrot and onion varieties across generations with no external seed source whatsoever. Certain crops, such as carrots and beets, are biennial, meaning they need 2 growing seasons to produce seed, and if you plan to collect seed from biennial crops, you must account for the extended time that garden space will be occupied. Accounting for that space is simply a matter of planning, and the payoff is a multi-year supply of seed from plants that were already growing in your garden and performing well in your specific conditions. Now bring all of this together into a complete integrated picture of what a seed-independent growing system actually looks like across one full calendar year. Because the elegance of how the different crops chain together is what makes the system truly powerful. In late summer and early autumn, you're saving tomato seeds through fermentation, drying pepper seeds on the kitchen counter, leaving bean and pea pods to rattle dry on the vine, and cutting green onion stumps to begin their water regeneration on the windowsill. In autumn, you're planting garlic cloves saved from summer's harvest, leaving carrot and beet roots in the ground for their second year seed production, and putting your newly dried seeds into labeled paper envelopes, glass jars, and a refrigerator shelf. Through winter, you are tending windowsill green onions and celery bases in water. planning which squash varieties you will blossom bag in spring, and choosing which sweet potatoes will be suspended in water to begin producing slips for the coming season. In spring, you're planting sweet potato slips, setting out rooted herb cuttings, planting potato eye sections that have been left to scab, and harvesting seed head stalks from the biennial crops that overwintered in the garden. One good growing season can produce many years' worth of seeds from these crops. This cascading chain means that no single failure, no single missed season, and no single bad harvest destroys the entire system, because the redundancy is built in through multiple crop types, multiple propagation methods, and multi-year seed viability and storage. Preserving heirloom seeds is not just about maintaining biodiversity, it is about safeguarding centuries of agricultural heritage and ensuring food security for future generations. And in a year like 2026, when fuel costs are elevated, electricity is uncertain, and the cost of everything from a seed packet to a bag of fertilizer reflects the instability of global supply chains, that agricultural heritage is not a sentimental idea, it is a material economic advantage. Saving seeds allows you to select and improve crop characteristics like flavor, vigor, nutritional quality, and regional adaptation. And these are not always the same goals for seed companies and breeders, who may focus on commercially important traits. The commercially important traits that seed companies breed for are almost always shelf life, uniformity in appearance, and transportability, none of which are traits that matter to a family growing food in their own backyard. What matters to you is flavor, yield in your specific climate and soil, resistance to the pests that actually live in your region, and the ability to reliably produce the next season's crop from the current one. And those are exactly the traits that open-pollinated seed saving selects for over time. Seed saving is also a great way to develop seed lines that are well adapted to a particular environment. And saving seed from the healthiest plants year after year enables growers to select for traits that are most suitable for their growing conditions. Every year that you save seeds from your best performers is a year of free personalized plant breeding. And over 5 to 10 years, the cumulative effect of that selection is a collection of varieties that are genuinely optimized for your patch of earth in a way that no commercially produced seed can match. Research analyzing nearly 40,000 germination test results over a 25-year period found that seed viability is well maintained for the large majority of seed lots during the first 25 years of proper storage. 25 years of viable seeds stored at home with nothing more than dried conditions, sealed glass jars, and a cool temperature, which means a small initial investment of time in learning the correct drying and storage protocols can create a seed reserve that outlasts a decade's worth of planting seasons. Food waste is a monumental problem for people and the planet, losing valuable calories that are directly linked to world hunger and contributing to greenhouse gas emissions as decomposing organic waste releases methane gas. But the flip side of that statistic is that every tomato seed you rescue from a fruit you would have composted, every potato eye you plant instead of discard, every celery base you place in water rather than throw away is a direct act of converting what was waste back into future food at zero cost. According to Love Food, Hate Waste Canada, an initiative by the National Zero Waste Council, 63% of the food we throw out could have otherwise been consumed. And propagating vegetable scraps is another efficient way to divert food waste and minimize what is sent to composting facilities while also lessening your carbon footprint. This connection between food waste reduction and food production through vegetative propagation is one of the most underappreciated links in the entire sustainable living conversation, and it transforms how you see the scraps on your cutting board. Now let us address the question that serious growers always ask at this point, which is, what about disease? And can saved seeds carry diseases that infect the next generation of plants? Transferring disease to the next generation of plants is a real concern, and in cases where the crop is infected with a seed-borne disease, a disease that can live for extended periods of time on the seed itself, the plants grown from that seed can become infected as well. This is the reason that selection of seed parent plants matters so profoundly, and why the advice to only save from the healthiest, most vigorous, disease-free individuals is not just aesthetic preference, but genuine disease management. Remove any weak diseased or off-type plants nearby to maintain genetic purity and prevent those genetics from contaminating your seed stock. If a plant shows signs of fungal spotting, mosaic virus symptoms, or any other visible disease, do not save seed from it regardless of how good the fruit looks, because the pathogen may be present in the seed even when the fruit appears healthy. After seed collection and before seed storage, seeds should be dried to the appropriate level of moisture content and relative humidity and packaged for storage in an appropriate airtight container. The step of achieving truly low moisture content before sealing seeds in storage containers is not optional. It is the single most important variable in seed longevity, and it is where most home growers make their most costly mistake. Conservation seed banks aim to maintain seed viability as long as possible by storing seeds under low temperatures and humidity to slow down internal chemical processes such as lipid peroxidation and DNA damage. Lipid peroxidation and DNA damage are the actual biological mechanisms that kill stored seeds. They are both driven by the same two enemies, heat and moisture, which confirms again that the solution is simple even if the science behind it is complex. One test that professional seed savers and commercial seed companies both use to verify storage success is the germination test, which is simply placing 10 seeds between damp paper towels at room temperature and counting how many germinate within the species. Specific window, and a result of 7 out of 10 or above means the seed lot is strong enough to plant with confidence. If you are depending on saved seeds for commercial production, testing for germination percentage about a month before the expected planting date is strongly recommended. For the home grower, this test takes 2 minutes to set up and tells you with confidence whether to plant your saved seeds, refresh them with a new saving cycle, or supplement with purchased seed for that particular season. The system described in this entire exploration does not require land ownership. It does not require electricity. It does not require expensive tools, and it does not require expertise that takes years to develop. It requires observation, patience, and a small collection of glass jars. Saving your own seeds can save money on future seed purchases, and sharing them with others helps grow community connections, as the stories of seeds and their cultivation are passed between growers. Saving seeds from your favorite heirloom varieties helps create resilient, locally adapted plants while reducing dependency on commercial seed suppliers. In a world where supply chains are volatile, where fuel prices make every transported product more expensive, where electricity cannot always be relied upon, and where the cost of living presses harder every season, the ability to grow your food without ever purchasing another seed is not a luxury skill or a nostalgic hobby. It is a concrete, practical form of economic self-sufficiency that is available to anyone with a window ledge, a garden bed, or even a few containers on a balcony. Seed saving is more than just a practical gardening technique. It is a vital way to protect plant diversity. And by preserving seeds from heirloom varieties, you're helping to safeguard unique traits that might otherwise be lost. And the future of food, especially in an unstable world, belongs not to whoever controls the largest seed vault in the Arctic, but to the millions of ordinary growers who quietly, season after season, dry their seeds, store them in jars, cut their potato eyes, root their herb stems, and keep the chain of living genetic memory going without asking permission from anyone. Nature has always known how to reproduce itself. It has been doing it for hundreds of millions of years, without a seed packet or a corporation in sight, and the only thing you need to do is learn to work with it rather than around it. Sometimes the most powerful technology is not something invented last year in a laboratory. It is something your great-grandparents did every single autumn as a matter of survival. And the only thing that stands between you and that knowledge is the willingness to let the tomato stay on the vine a little longer.